If I asked you where the solar system ends, what would you say? The orbit of Neptune? Or maybe the Kuiper Belt, home to distant Pluto? Most of us picture our cosmic home exactly like that, a set of planets orbiting the sun, and we're used to thinking that where the last planets end, our home ends. But that is an illusion. The real border isn't where the last icy rock flies. The real border is physical. It is a wall where the dominion of our sun ends and the infinite radioactive ocean of the galaxy begins. Scientists argued for decades about where it was. But recently, we didn't just find it, we slammed into it. And what we saw there, a wall of plasma fire and magnetic anomalies. To understand where the exit is, we need to understand the anatomy. The solar system isn't just a gravitational trap, it is a giant bubble called the Heliosphere. The sun is constantly blowing a stream of charged particles in all directions. This is called the solar wind. It rushes out at millions of kilometers per hour, pushing back the interstellar gas. But space isn't empty. The galaxy is pushing back from the outside. Our bubble doesn't have just one border, but two, and it is important to distinguish between them. The first is called the Termination Shock. Picture this. The solar wind is flying at supersonic speeds. But as it gets further from the sun, the pressure of the interstellar medium increases. At some point, the wind slams on the brakes. It's the reverse of what happens when a jet breaks the sound barrier. The wind compresses, heats up, and slows down. But that's not the end of the system yet. Beyond the shock wave lies the Heliosphère, the turbulent anteroom of our system, and only beyond that lies the Heliopause, the final frontier, the place where the sun's pressure finally loses to the galaxy's pressure. It is precisely behind this line that true interstellar space begins. For a long time, all of this was just theory on paper. To verify it, we needed a ship capable of reaching the edge of the abyss. In 1977, humanity launched the Voyager probes, and here is the irony: no one planned for them to go looking for the edge of the system. Their mission was designed to last only 5 years, to study Jupiter and Saturn, but incredible luck intervened. A rare planetary alignment, which happens once every 177 years, allowed the probes to perform a series of gravity assists. By jumping from planet to planet, they accelerated to 17 kilometers per second. When the primary mission ended, engineers made a bold decision. They reprogrammed the spacecraft. They began turning off cameras and heaters, saving every watt of energy from the decaying plutonium. The Voyagers were given a new goal: to fly as long as their strength lasted, to fly into the void, to find the edge. Decades passed. The probes moved 120 astronomical units away from Earth. Scientists expected the plasma temperature to drop at the boundary. Space is cold, right? But the sensors showed something impossible. Right before the heliopause, the probes entered a layer of compressed plasma. The temperature outside spiked to 30,000, and in some places up to 50,000 degrees Celsius. The media immediately dubbed it the Wall of Fire. Wait, 50,000 degrees. The melting point of aluminum is only 660 degrees. Why didn't the probes vaporize instantly? Here, earthly intuition fails us. In space, we must distinguish between temperature and heat. Temperature is the speed of particle motion. In this wall, the particles are indeed racing with insane energy, but there are vanishingly few of them. The density of the medium is so low that these scorching atoms almost never hit the ship's hull. It's like sticking your hand into a hot oven. The air inside is hot, but you don't get burned instantly because the air is thin. Now imagine the air density is billions of times lower. For Voyager, this was a cold inferno. Energies of incredible power raged around it, yet the ship itself continued to freeze. And then, the moment arrived. On August 25, 2012, Voyager 1's instruments recorded a sharp drop. The solar wind disappeared completely, and the level of galactic radiation skyrocketed. For the first time in history, humanity had entered interstellar space. 6 years later, in 2018, Voyager 2 repeated this feat. Data from the two spacecraft brought new mysteries. First, the magnetic field. Scientists were sure that outside the system, magnetic field lines would change direction, but the probes showed that the sun's and the galaxy's fields were strangely aligned, almost parallel. Second, the shape. We realized the heliosphere isn't a sphere. We are hurtling through the galaxy, and the headwind crumples our bubble. Modern models, built on Voyager data, suggest our system looks like a squashed croissant or a shrimp with two tails. Why is it even important for us to know where this border is and what shape it takes? Because the heliosphere is our main shield. The galaxy is a deadly place. Cosmic rays from supernova explosions can shred DNA and sterilize planets. The heliosphere cuts off up to 70% of this deadly radiation. If not for this bubble, life on Earth might never have emerged. But this shield isn't eternal. The sun moves through the galaxy and sometimes passes through dense clouds of gas and dust. Recent studies show that about 2 million years ago, we passed through such a cold cloud. The heliosphere shrank, leaving Earth exposed. Scientists found traces of iron-60 and plutonium isotopes in Antarctic ice dating back to that period. This coincides with ice ages and extinctions. We depend on the breathing of our bubble more than we can imagine. The Voyagers achieved the impossible, but they are 1970s technology. We saw the border at only 2 points. That's like judging the shape of an elephant by touching the tip of its trunk and its tail. We need to see the whole picture. That is why scientists are developing a new mission, the Interstellar probe. This spacecraft needs to be faster and longer lasting. Its goal is to reach a distance of 1,000 astronomical units, 10 times farther than Voyager 1 is now. The plan is to fly far beyond the wall of fire, turn around, and do what its predecessors couldn't, photograph our home from the outside, to see our protective bubble in its entirety against the blackness of space. But while the new probe remains just a project, our old heroes are fading. Their radioisotope generators are losing 4 watts of power per year. NASA has already started turning off scientific instruments one by one. First the heaters, then the plasma detectors. Engineers say that by 2030, there won't be enough energy even to transmit a signal. The Voyagers will go silent forever. We will no longer hear their call signs, but their mission will not end. On board each spacecraft is the golden record. Bach, Mozart, the sound of rain, greetings in 55 languages. In 40,000 years, they will pass by other stars. Millions of years from now, when nothing may remain of Earth, these little robots will fly in the silence. Dead, cold, but carrying proof that we existed, that we were curious, and that we found the courage to reach for the edge of the world. So where does the solar system end? It doesn't end at Pluto. It ends where the wind of our star dies down. It is a living, breathing, hot border that protects us from the cold abyss. And we are only just beginning to understand how fragile this balance is.